Alright, homework 3 here. We're going to look at arranging these numbers in ascending order. So we have to maybe come up with an approximation of each one. So what we can see here is that 2 pi, well pi is about 3, so 2 pi is going to be something bigger than 6. So let's leave that for now. Let's work maybe the second one out as a mixed numeral. So with how many whole numbers, how many times does 3 go into 14? And we know 3 times 4 is 12, so this number here will be 4 and the remainder is 2, so 4 and 2/3. This number here, well, let's look at root 3. We know that root 3 is less than the square root of 4, and that's 2. So this whole number has to be less than 2 times 2. So it's going to be something less than 4. And if we compare these two, well, this decimal here is 5.0303, etc. So we can see that that is bigger than the decimal before it. So if we want to write these in ascending order, what we've done is enough. So in ascending order, remember we're going to use the original numbers as they're written. So the smallest one will be first. The smallest one I think we can see is 2 root 3, because that was less than 4. So there's that one done. The next one was the one that's a little bit bigger than 4, so 14/3. The next biggest, well, we have 5.03, because remember that was smaller than 5.03, both the 0 and the 3 repeating. And the biggest one is 2 pi, because that was bigger than 6. So we didn't have to actually calculate the values exactly, we could just compare them to arrange them in order. For question 2, we're going to use the idea of creating equivalent fractions underneath the square root. So we want to insert 2 real numbers, so we're going to have to multiply by at least 3 in the numerator and denominator. So multiplying by 1, but of course 3/3. This is the same fraction here, and if we multiply the second fraction by 3, we'd have 9/21. So 2 in between there, I think we can see relatively easily that it's going to be 7/21, which we can simplify to the square root of 1/3, and also the square root of 8/21. So there are 2 rational numbers. There are in fact infinite solutions, so there's possibly a variety of correct answers for that question. Question number 3, we're back to our ordering. So if we look in this, compare the numerators and the denominators, we see that the denominators are probably the easiest to compare with the common factors. So you can see that they're all multiples of 3, so let's pick a convenient number that can combine those denominators. The 6 and 12 are easy to compare, but the 9 makes it a little bit difficult, but we should be able to find that the lowest common multiple is 36. So we're going to write all of these fractions out of 36. So the first fraction we'd have to multiply by 6/6, so minus 30. The second fraction we'd have to multiply by 4, so that would give us minus 28. And the third fraction we'd have to multiply by 3. So now we should be able to compare these. Remember, we're looking at ascending order, so the smallest will come first. So the smallest is actually the most negative number. So minus 30, we should go back to the original things. The first one we want is Z. So let's start again. Z, and then the next smallest is the next most negative. It's the first one, X, and then Y. Okay, for part B, I think we can see here that the numerators are easier to compare. So we want to have a common factor. Well, 4 and 12 are easy to compare. The 8's a little bit more difficult. So let's choose something that we can find. I think 24 will work nicely. So if we make all of these numerators 24, we should be able to compare the denominators for each rational number. So for the first fraction, we're multiplying numerator and denominator by 6. By 6. So that's 18. So from 8 to 24, it's multiplying by 3. From 12 to 11, it's doubling. So to see which one's the smallest, it's going to have the biggest denominator. So we can see the last one is the smallest. So the order will be Z. The next biggest is for Y, and then the largest number there will be x. Okay, so in part C, if we look here, we can see that the numerators, again, easier to compare, and if we pick a common multiple there, it looks like 18 is going to work quite well. So let's put them all over 18, or minus 18, shall we say. Minus 18. So we're multiplying the first fraction by 6 over 6, which will give us 12. The second we're multiplying by 3 over 3, so 15. Notice that I've just changed the negative to the numerator. It's still, the fraction will be negative. In Z, we've got multiplying by 2, give us 16. So they're using the same comparative thing we did with B. The smallest number will have the largest denominator, so we can see that it's Z, then Y, and then X. Okay, so for D, this time we have 4 fractions, and the numerators and the denominators are not very easy to compare, because in the denominators we've got this 17, which is a bit tricky, and 7 and 3 and of course 16 don't match up quite well in the numerators. But we can use a bit of common sense here. We know that a half is much less than 3/4 and much less than 7 over 8. And we know that this 16 over 17, well, that's very close to 1, because the numerator and denominator are very close. So we should be able to see here that t is the smallest. And then just comparing the other ones, we've got just a 1 difference in the numerator and denominator, but as those numbers get larger, this is getting closer to 1. So 7 over 8 is closer to 1 than 3 over 4. So 3 over 4 is the next smallest, then x, and the largest there will be y. So we can use a little bit of comparison as well. So in summary, with the ordering of numbers, we can do some approximations. We can find some equivalent fractions using either the denominator or the numerator, as in these two cases, or sometimes we could just use our understanding of which numbers are closer to 1 using just comparing the numerators and denominators here.